My Lords, I thank the committee and the Noble Lady Baroness Brown for their careful, detailed work and informative introduction. I have 2 points to make about the general approach and also about risk, and I'm taking a different, rather more sceptical approach than we've heard from speakers thus far. First, to start with a traditional metaphor fitting with myself as a carpenter's daughter, if you only have a hammer, then everything looks like a nail. I note that the committee did not address, and I understand that it may not have considered it within the scope of its inquiry, consideration of what problems and issues are appropriate for synthetic biology solutions and what needs different approaches. But if we're going to avoid silos and have joined-up systematic government, we need it and the Parliament to think about prioritisation, to think about funding, even about rhetoric and policies, about what problems, what big crises our societies face, and whether synthetic biology is the best way to tackle them. Human time, talents and money are all scarce resources. They need to be used well and not in dangerous direction or into dead ends. I'll be revisiting these issues with my fatal motion on the gene editing regulations next Tuesday, but to use an example to illustrate my point. Science Alert yesterday published an article titled "Scientists Engineer Bacteria to Make Soils and Crops Glow Different Colours." It quoted an MIT researcher explaining, adding 2 different bacteria could in effect make the fields grow red when pollutants take hold and green when nutrients are high. So it might respond to metals or radiation or toxins in the soil or nutrients in the soil. So we're talking about messing with bacteria, the genetic makeup of bacteria, letting them loose on the world to know if a field is contaminated with heavy metals or if you've applied too much fertiliser. I would posit that there are other approaches here. You could have land managed and cared for by a farmer or grower, informed by government-funded expert agroecological research, who intimately understands every corner, who is protected by a society that has adequate regulation that ensures she won't be pushed to spread on its sewage sludge contaminated by heavy metals or forced to use irrigation water loaded with pesticides and pharmaceuticals. We need to stop assuming that we can make a mess, destroy the immensely complex Earth systems developed over 4 billion years, and just engineer something to fix it. That's solutionism, and only operates to magnify and allow for a while the damage to continue. There are problems. The need urgently to develop a vaccine against SARS-CoV-2, for example, for which synthetic biology is the right emergency response. But rather than assuming we can always scramble to that point, we need to think about how we stop the crises emerging in the first place. Synthetic biology can't help us there. Ultimately, we need, as the Oxford geographer Jamie Lorimer explains, to work our way towards a probiotic, a healthy society and planet. Now, the final 6 pages of the report talks about risks, focused particularly, and with good cause, on the danger of inappropriate technology and materials falling into ill-intentioned and ill-prepared hands. This is an important issue, and I'm pleased to see the focus here. But there is no real focus on the general systemic risks of messing around with an immensely complex biological system, of which we are, to compare with the education of a child, around early to middle primary in our understanding. We've just about mastered basic mental arithmetic, while life is operating at the level of the most sophisticated maths professor. And mucking with systems, synthetic biology is mucking with systems that we just do not understand. To illustrate that, I draw on another piece of just emerging knowledge, an absolutely fascinating paradigm-shifting discovery. And I'll point here as a reference to a Nature article published on the 8th of April titled "Cells are Swapping Their Mitochondria. What does this mean for our health?" That's something that mitochondria can swap around cells is an entirely new discovery. It's massive. Most, probably nearly all, of our synthetic biology does not take into effect how gene editing of cellular material might interact with that. So ultimately, just one final extra thought here. Example of how we have inherited from the 20th century lots of ideas that we need to unlearn. Francis Crick's central dogma It's grounded in Crick's reductionist belief in the possibility of explaining biological entities in terms of their physical and chemical components. He was absolutely wrong. Ultimately, I would urge at the base consideration the phrase engineering biology. You can engineer machines, but life, living organisms and ecosystems are nothing like machines. We need to acknowledge and examine carefully that long-running category error we inherited from the 20th century.